So in this next video, we're going to continue to find some exact values, but the information that I'm giving you is a little different. So in this first one, I'm telling you we have two angles, theta and beta, and that they're in quad 3. Right? So that tells us information about the signs of cosines and sines and whatnot. And then I'm telling you that the cosine of theta is -8/17, and the sine of beta is -3/5. And I want to find the exact value of the cosine of theta minus beta. All right, so we're kind of working in reverse. So using the identity, what do we know about the cosine of theta minus beta? Well, the identity says this is the cosine of theta times the cosine of beta plus the sine of theta times the sine of beta. All right, so that's what we have. Using what we got, we know that the cosine of theta is -8/17. Cosine of beta is not given, and then the sine of theta is not given, but the sine of beta is -3/5. All right, so to finish this off then, what we need to do is figure out what's the cosine of beta and what's the sine of theta based off the information that I have. All right, and so we basically have several ways to do this. We've got our x, y, r definitions. We can use a corresponding right triangle, or we can use trig identities. Okay, and so you're going to see me doing a little bit of mix and match, kind of some nice review for some situations. What I'm going to choose to do in this one is use the trig identity since we're kind of on that. So what do we know about cosine and sine? Well, for any angle, we know that the cosine squared theta plus the sine squared theta is equal to 1. So since I know the cosine, I can basically find the sine. All right, and so sine squared theta is basically 1 minus, let me just write this as 64/17 squared. I don't want to press up my calculator. So what we basically have here is sine squared theta will be 17 squared minus 64 all over 17 squared. So I'll bust out the calculator at this point. Come on. Got to turn it on. I think my calculator will handle this. Let me get rid of this and just type in what the heck is 17 squared. So 17 squared equals 289. So we have the sine squared theta equals 289 minus 64 all over 289. And if we subtract 64, what we get is 225. So sine squared theta equals 225 over 289. If we take a square root, we introduce a plus minus. Since we're in quad 3, we know that it's going to be the -1. So sine of theta is negative. We already know that the square root of 289 is 17, and I believe the square root of 225 is 15. And I'll just double check that with my calculator real quick. So 225, take the square, the square root of 225 equals 15, just like I thought. So there, after all that work, is the sine of theta. So we can come back over here and replace the sine of theta with -15/17 and -3/5. So now we got to find the cosine of beta. All right. Again, we have a couple of ways we can do that. We could use another identity, right? Or we can use our x, y, or right triangle definitions. You basically choose. Since we've done the identity, how about I do a right triangle? So in this situation, beta is in quad number 3. So my corresponding right triangle, this is for beta and this is for theta, right? Sine is y over r. So this is basically telling us that our y value is -3 and our r value is 5. So we basically need to figure out what x is. And so we know that x squared plus y squared equals r squared. So we would get x squared plus -3 squared equals 5 squared. This is basically x squared equals 25 minus 9. X squared equals 16. Take a square root, introduce a plus minus, and we want the -4. And the reason we want a negative 4 is because we're in quad 3. So our cosine then of beta is x over r, so this is negative 4 over 5. Okay, so we can finally get that done. So again, a mix and match. Hopefully it's a good review of stuff we've done before. So the identity was the easy part. It was finding the trig function values that I needed was hard. And I chose 2 paths to go by just to do some review. So I used the triangle and a trig identity to do that, and hopefully good review. So finishing this off, negative 8 times negative 4 is a negative 32, and then 17 times 5, 34, 68. Let's bust out my calculator. All right, 17 times 5, 85. All right, so 85. Here we get a negative 45 over 85, and so adding these together, it looks like we get 5, 2 is 7, 7. So negative 77 over 85 is the exact value for that, all right, using what we have learned. Okay, so let's go ahead and go to the next one. Here we're told that theta is in quad 3 and beta is in quad 2. We know that the tangent of theta is a half and the sine of beta is 1/4. And so they want us to find the exact value of cosine of theta plus beta. Well, again, it'll start off, what do we know about the cosine of theta plus beta? Well, under the identity, it's the cosine of theta, cosine of beta, minus the sine of theta, sine of beta. And so good news here, right? We have at least the sine of beta. But we don't know the cosine of theta, the cosine of beta, or the sine of theta. And so we're kind of stuck. So what do? Well, we start using, right, either XYR definitions, right triangles, or trig identities to fit the situation. So let's go ahead then. In quadrant number 3, if we use this, right, so this is the work for theta, we know that x, this is y over x, but they both have to be negative. So x is negative 2 and y is negative 1 in quadrant number 3. So this basically means that x squared plus y squared is r squared, and so we get negative 2 squared, negative 1 squared equals r squared equals 5, take a square root, and we have plus or minus the square root of 5. But we know that r is always positive. So there's our r. So now that we have the r and the x and the y for theta, I can find the other guys. So cosine of theta would be the x value over the r value. Rationalizing the denominator, we get negative 2 square roots of 5 all over 5. The sine of theta, well, that would be the y value over the r. Rationalizing my denominator, we get negative square roots of 5 over 5. All right, so we got cosine and we got sine. So I can come back over here. The cosine is negative 2 square roots of 5. The sine is negative square roots of 5 over 5. And so all that's left is finding our cosine of beta. So what's our beta action doing? Well, we know that beta is in quad number 2. And the sine is 1 over 4. So there's my y and my r. I'm actually going to use a right triangle for this situation. So in quadrant number 2, this would mean that my y value is 1, my r value is 4, so we basically have to find our x value. And so x squared plus 1 squared equals r squared. And so x squared, this would be 16 minus 1, so x squared equals 15. Taking the square root, we get plus or minus the square root of 15. Since I'm in quad number 2, this means that our x is negative square roots of 15. So what's our cosine of beta? It's this x value all over r value, which was 4. So we got that. So I can come back over here and substitute what we know for that. And if we clean this up, I think this is negative 2 square roots of 65 all over 20 minus a minus and a minus, that's actually plus square root of 5 over 20. So our exact value, if we put this all together, is that negative 2 square root of 65 plus the square root of 15, oops, all over 20. And so there's how you basically find some exact values, kind of in reverse. We're trying to find the cosine of a difference or the cosine of a sum, and we basically use what we have, and then it's a mix and match. And you go ahead, and I know you guys will probably like the X, Y's, R's. I know that's the easiest, but for the sake of review, I will show you right triangles and trig identities. So be aware, I might ask for those on quizzes. So be heads up. It's a good review of all our different trig things that we've done in the past to get you ready for a final if those of you want to take that final eventually. All right, so that's that. We're going to move on to simplifying and verifying proofs, but we'll do that in a new video coming soon.